A very warm welcome in the course of numerical methods. We are now in the module of interpolation, and now from this particular lecture we have entered in the exact discussion of interpolation, because in the previous lectures already we have discussed the prerequisites of interpolations. So now today our topic is Lagrange's interpolation. So let us see what are the given things, what we are going to do, and how we are going to do through this particular formula. Basically, our requirement is that when we don't know the explicit relationship of y with x, where y is our dependent variable and x is our independent variable, when this expression is not explicitly known to us, but instead of that we are having some data which gives some idea of this particular relationship. Now already, if you can recall the first part of this particular module, we have discussed about equispaced data as well as unequispaced data. So think about it. When we are having, suppose, our census, so we are getting the data in general in this structured form. Suppose this is our year and this is the population in crores. So in the year 1981, in the year 1991, in the year 2001, in the year 2011, and I don't know whether in the year 2021 it is done or not because of corona, So suppose it is 130 crore, it is 110 crore, and suppose this is 80 crore, and suppose this is 70 crore. I don't know whether these are the exact data or not. Just I am writing for our example purpose. Now look at this. From first observation we can make that this data is an equispaced data, because we are collecting the data where our independent variable is having same spacing, here 10 years gap. And as well as I am also giving you another information, another example. I can say that suppose when we are having the density of our cars in a city or in Kolkata, where we are taking the time and the density. So suppose at 10 a.m., at 11 a.m., at 12 noon, after that at 2 p.m., then 4 p.m., then 6 p.m., and then 7 p.m. I am taking the data. You can ask me, sir, why this is the data, this collection is not evenly distributed? You can see that yes, it is not evenly distributed and it falls into unequispaced data. We don't know what is the density, we don't want to know at this moment, because when we are judging whether it is equispaced or not, we don't need to see on this. Now both type of data collections are important, because when you are thinking about census, it has to be equispaced. But when you are thinking about the density of the cars in a particular location in a city, obviously you will collect the data when the office time is there. So you are collecting the data at 1 hour gap. After that, you know that in this span the number of cars will be less, so there is no need to collect the data. That is why the data is not collected also. and here we are getting 2 hours of gap, and after that when the returning time is on, then again we have started collecting 1 hour gap, and it may be that at 12 midnight, if you are thinking about, and then you are going to collect the data at 4 a.m. because this will be the time duration where the number of cars will be very less in a particular route. So here there is no benefit of taking the data from 12, then 1 a.m., then 2 a.m., then 3 a.m. and so on. So both the things are rational and realistic. But in these two cases, if it is important to know for any reason that what is the population in the year 1985, obviously it is not possible for us to say it exactly because we have not collected the data in the year 1985. But we will not do here any guess. We will try to find out the answer of this question by one process, mathematical process, which involves these informations, and then we are going to say that maybe this will be the value we are having in the year 1985, and we can claim this value because the function or the polynomial what we are going to generate will satisfy all the values in the given data set. This is the main fundamental part of this process. We are now claiming this process for equispaced data as well as for unequispaced data. Maybe there are two different approaches, but the generalized name is called here interpolation. And the fundamental criteria for a standard interpolation formula is that you are going to find out and interpolating polynomial by various means which will satisfy all the points which are given. That means in this polynomial, if you put 1981 as your input, then you obviously get 70 crores as the output. Similarly, if you put 1991, you will get 80 crores as the output, and so on. That means actually we are going to construct the interpolating polynomial based on this data set. So if this data set is not given to us or not known to us, we don't have any idea how to speculate or predict the population in the year 1985. Now, there are some interpolating polynomials or interpolation formula which only be effective on equispaced data, and there are some interpolating polynomials or interpolation formula where they are both effective on equispaced data as well as unequispaced data. So today our target is to discuss one interpolation formula whose name is Lagrange's interpolating polynomial or Lagrange's interpolation formula, which will be used for both the cases. So let us give the working rule. Obviously in the class I will show how to prove it and from where it came, but now just as a pre-read for this particular topic, I am giving you the information as, suppose you have a data set, given data set where x and y is collected, and in general it is x0, x1 dot 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 xn, it is y0, y1 dot 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 yn. First information is that there are n plus 1 number of data, and using them you can find out a polynomial with at most nth degree, and that interpolating polynomial, if constructed in this structure, then it is called Lagrange's interpolation formula. And what is this polynomial? I am now going to write it down. Px is y0 x minus x1 x minus x2 dot 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 x minus xn by x0 minus x1 x0 minus x2 x0 minus xn plus. This is your first term, and you can see that in the denominator all of them are constants because all of them are known to us, and in the numerator you are getting n linear factors are multiplied. That means the simplification will give you in the numerator as x to the power n as the highest term, so the polynomial will be of x to the power n if I consider only this term, but obviously the other terms are coming, and look at this how the other terms are there. There is a very beautiful symmetry present over here. So y1, then it is x minus x0, then x minus x2. Look at this, when you are talking about y1, that means something corresponding to x1. x1 will not be there in the numerator, as well as in the denominator you will get everything will be subtracted from x1. So x1 minus x0, x1 minus x2, because x1 minus x1 will not be there, and in the same manner x1 minus xn. So in this way, if you go for the generalized term, that is ith term, so it will be yi x minus x0 x minus x1. If you understand the symmetry of this term, then it is enough for writing others. X minus xi minus 1, then x minus xi plus 1, because x minus xi will not be there, and it is then x minus xn. Then in the denominator it will be xi minus x0 xi minus x1. Just the numerator will be written, only x will be substituted by xi. Then xi minus xi plus 1, and then xi minus xn, and the last term will be yn x minus x0 x minus x1 x minus xn minus 1, and in the denominator you will get xn minus x0 xn minus x1, in a similar manner xn minus xn minus 1 whole stop. So this is your whole interpolating polynomial, where you can see that starting from y0 y1 y2 yi yn, everything is used. So all the values what we got from the table, we have used it, and in each and every term we are getting one nth degree polynomial, and if we sum them up we will be again in the nth degree polynomial, which is actually the intended interpolating polynomial through Lagrange's method. Now if we want to solve one problem, a very simple problem with this, then what will be the structure? Let us initiate it. So suppose one table is given to you, x, y, and look at this, in the whole structure there we have not used any h. That means this particular interpolating polynomial can be used for equispaced as well as unequispaced data. Suppose just arbitrarily I have taken this data set 0, 1, 3, where the corresponding functional values are 0, 3, 7. So if I want to write the interpolating polynomial for this particular problem, I will write y0, then x minus x1, x minus x2, because we can see that there are three values, so the interpolating polynomial will be of degree 2 maximum, and then it will be x0 minus x1, x0 minus x2 plus y1, x minus x0, x minus x2 divided by x1 minus x0, x1 minus x2 plus y2, x minus x0, x minus x1, then x1, x2 minus x0, x2 minus x1. So now the remaining part is very easy. We can just check this, that it is my x0, x1, x2, this is my y0, y1, y2. So here we can write 0. Obviously I am not going to write anything because already I have observed it that it is 0, plus y1, that is 3, then x minus x0, that is 0, and x minus x2, that is 3, then x1 minus x0, that is 1 minus 0, that is 1, and x1 minus x2, that is 1 minus 3, that is minus 2, plus y2 is 7, then x minus x0, that is x minus 0, then x minus x1, that is x minus 1, and x2 minus x0, that is 3, into x2 minus x1 is 3 minus 1, that is 2. So simplifying it, we can write it as minus 3 by 2 x into x minus 3 plus 7 by 6 x into x minus 1, and after that if I simplify it, obviously I will get minus 3 by 2, it is x square minus 3x, then plus 7 by 6 x square minus x. The remaining part is kept for u. Finally, obviously you will get something like that, ax square plus bx plus c as the interpolating polynomial for this part. So I am not extending this particular discussion anymore. I think all of you got the philosophy of Lagrange's interpolation formula, and you will be also very much helpful if you go for these references, and also the problems like this where we are going to apply Lagrange's interpolation formula for finding out the fx. And after finding out the fx, obviously if some value in the given interval of x is asked where the functional value is not known, we can find it out just by putting that value in that interpolating polynomial. So thank you all, happy listening, happy learning.